students, we have to in this lecture I have to construct the stiffness matrix of a space frame. And in the previous lecture, I explained to you how to solve space frame on a stiffness method. Okay, we have for this frame I have a ki is equal to 6j minus r, and number of joints I have 1 2 3 and 4 5 6. I have 6 joints, and number of support reactions 6 6 6 and 6, so I have 24. So it comes out to be 12 degrees. But in this question, the statement is not written, but it is given in the question that you have to ignore the axial deformations. To ignore the axial deformations, you have to minus the number of members. So I have 1 member, 2 member, 3 member, 4 and 5 members. So I'll minus 12 minus 5 and I'll get 7 degrees. In order to visualize the Ki of this structure, I can represent the Ki or show to you like this. Fixed support and fixed support as well. So let me show this Ki in another color, for example this color. So Ki here is actually for every joint we have got 6 equations and 6 degree of freedom, this and this and this, and obviously I have got 6 moments. So here I have this moment, because for every joint we have got 6 equations. 6 equations means 6 members, 6 unknown parameters. But as we are ignoring the axial deformation, that members are axially quite stiff, so they can resist the axial deformation. So for this column, this would be the axial deformation. For this beam, this would be the axial deformation. For this column, the axial deformation is this. For this beam, the axial deformation is this. So in total, I have okay, one more thing. This is a beam and one axial deformation is this and one is this. So why not minus this? So one can be reduced because they are two, so you can reduce one. This would be the axial deformation, or this would be the axial deformation. One would still remain there and it would be considered as sway for the frame. So in total, 1 degree of freedom, 2 degree of freedom, 3 4 5 6 and 7. So we have 7 here, and I have shown here. So it's arbitrary. It can be your 1, it can be your 2, it can be your 3, it can be your 4, it can be your 5, it can be your 6, but there would be one Sidesway, and this is Sidesway here. So one by one I have to apply the degree of freedom, and I have to calculate the reactions, and I have to construct the stiffness matrix. Okay, for number 1 I have to keep, now the equation is I have to keep d1 is equal to 1 and d2 to d7 all are 0. It means all other degree of freedoms are restrained. So I have applied a fixed support here. Okay, so let me draw again so that you can understand more clearly. And this is your fixed support. So I'm applying d1 is equal to 1. So d1 is equal to 1 means, okay, let me try this black pen. I have to give, yes, this would be, I have to rotate this joint. And you know, when this joint is rotated, it would be equal to Gj by L, because it would be torsion for this and it would be resisted here, Gj by L. And Gj value is 5 and this is 20. This means 0.25. 0.25, and it is 0.25, right? Now in the shoulder members, moments would be produced. The magnitude would be 4 EI, as moment is in x, so 4 EIX by L. So 4 into EIX is 8 the length of this beam is 40. 410 gives us 0.8. Obviously this is 2 EI by L or half of it, so I can show it to be 0.4. Okay, how about this column? This would be equal to 4 EIX by L. That means 4 into EIX is 8, and the length of the column would be written here, and it is the length of column is 12, so it comes out to be 0.2666, and it would be half. It is 2 EIX by L, or simply 0.133. Okay, one another thing that I have to write the equations, or the reactions are important. This is in Z, X, this is Y, so there would be a reaction here in Z direction. This is anti-clockwise, so I am applying it like this because it would cause a clockwise moment here and resistive is applied. So your practice should be, you have practiced a lot, so you can actually apply moment using intuition or guesses. It's very easy. I have to balance this, so I am applying this. The magnitude of this would be 6 EIX by L square, and same would be here. EIX is because the moments were in X, so I am using X EIX. 6 into 8, L is 12 square, one because this is a column of 12 feet height, and you will solve it and you will get 0.33. Similarly, you can do it for this. This is your X beam, this is Z, this is X, so there would be reaction in Y. It can be there, and it should be like this. It would be balanced here. It is causing a clockwise moment, so it is anti. The magnitude would be 6 EIX, same. Length would be 40 square. Actually, I don't need this. That's why I haven't used it, because you may see, you have to, it's actually a common sense that I have a reaction here in Z direction. That's why I am needing these. There is no degree of freedom corresponding to Y direction here. No axial deformation. Moments are there, but I don't need these loads. Therefore, I haven't. You can find it, but I don't need it. Okay, it is done. Now the next step is to apply D2 is equal to 1, which is actually D1 has been done. I'll do D4 is same as D1, so I'm not going to do that. We can do 2 or 3. I'll select 1. 1 will be done by you because 1 and 4 are quite similar, so it's easy. I'll do 3. I'll be doing 3. Okay, you will be doing 2. Okay, based on this, I have done this activity, so I can compute the stiffness matrix. The order of stiffness matrix would be 7 cross 7 because there are 7 degree of freedom. So everything would be like this: S7, 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 S7 again, S7 again, sorry, 7, S7 again, 1, 2, 3, 4, and one more, S7 again. It would be 1. 1 means corresponding to this. And corresponding to this, I have these things. So S17 would be equal to 0.8, 0.25, 0.266. It comes out to be 3.716. Very simple. S27 means corresponding to this direction, and here I have nothing, no moment here. So S27 is 0. It is 0. S37 means corresponding to this vertical. I have got no moment here, it's 0 again. 47 is corresponding to this. Here I have 0.4, so it is in the same direction as that of this, so it would be plus 0.4. 51, S57. Actually I have done one thing wrong. I have applied d1 is equal to 1, so these should all be 1. This is my mistake, so you should clear it. This is 1, this is 1, because I have applied d1 is equal to 1, so all should be 1 here. The second number would be 1 always, because I have applied d1 is equal to 1. Now S61 means corresponding to this. I have got no moment here, so 61 is 0. 51 means 55. Where is 5? This. I have got no moment here, so 51 is 0 as well. Finally S71. 7 is this axial deformation, or corresponding to this I have got 0.33, but the direction is opposite, so I can write minus 0.33. So I am done with this. You will be doing this 4. Now I am going to do this S5, this 5, because 2 would be same as 5. Then I'll be doing 3 or 6 depending upon the situation. So I am going to do this one, 5. This is 5. Now I have to redraw, and let me draw very sparsely so that it is easy to understand for you people. And let me change the pen. Okay, the thing is 5 is actually the rotation in this direction, so I'll apply this like this. Okay. This is in Z, so I'll be doing this. Now this is torsion Gj by L. Its magnitude would be Gj is 5, and this length is 40 feet, I think. This length is 40 feet, and Gj is 5. This is 20, and column is 12. So Gj is 5 by 40, because this length is 40. This is 40. Gj by L is 40. It would be, and also you have to resist this. I mean, you have to restrain it. And that this would be 5 by 40 as well. So if you divide 5 by 40, I have the calculator. I don't have the, yes, I have the calculator. 5 by 40, 5 by 40 comes out to be 0.125. Yes, it is 0.125. As a result, okay, this would be the torsion here in this beam. Here, shoulder moments would be produced. Its magnitude would be equal to 4 EI by L. And the X EIZ would be used because it is the moment in Z direction. So for EIZ is 6. The length of the, because this is a column, so length of the column 12 feet would be used. So it comes out to be 2. Here it would be half of it, or 2 EIZ by L. So simply I call it 1. Here again the moment would be produced and the magnitude would be equal to 4 EIZ by L. So 4 into EIZ is again, I have done it 6. Length is 20. It comes out to be 1.2. This would be half, 0.6. I don't need any loading here. I need not apply any load on it. For the reason, let me tell you. Like, you know, this is member in Z, X, this is in Z. So I have to apply a load here. This is anti-clockwise, so it should be like this, and it would be balanced here, and its magnitude would be equal to 6 EIZ by L square. But actually this is not corresponding to any degree of freedom. The degree of freedoms are 3 moments here, and 1 side sway. So I am interested in if there is a loading here in this direction. Similarly here, the moments are in Z and this is in y, so the loading would be in this direction. Again, this is not corresponding to this, therefore I have skipped the loading here and I've made my calculations very easy. So it's very easy point, but you have to understand it. Okay, now I have to, as d5 I have applied all d5, so I'll have like this: d5, s5, 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 and we have to write 7 at least. 1 5 2 5 3 5. Okay, what is 1 2 3? 1 2 3. 1 is this, 2 is this, 3 is this. 1 2 3. So here I have got actually 1 was here, 2 was here, and 3 is here. So corresponding to 1 I have got nothing, so this should be 0. Corresponding to 2, nothing, so it should be 0. It is 0.125. 3 5, nothing here, so it is 0. Now the major activity comes. 4 5 6. What are 4? 4 5 and 6. 6 is upward. 4, nothing. Actually 4 is in this direction. 5 is in this direction. So 4 is 0. However, 5 S5 5 is a crucial activity here. I have to sum up all these things. 2, 1.2 and 0.125, and it comes out to be 3.325. 6 is vertical reaction here. I mean 6 is here, and I've got nothing here. It comes out to be 6 5 comes out to be 0. And S7 5, what is S7? Actually S7 is actually in this direction. You can see 7, S7 is this. This is a Sidesway, and I have got no loading here, so S75 would be 0. Okay, I have done this, and the final thing is going to be for okay, ultimately I'll be doing 3 and 6 would be same, so I'm doing 3, and then I'll do 7. So let me do 3. This is 3. So let me draw it again, and let me draw again very sparsely so that it's very easy to. And let me change the pen. Okay, the thing is S3 is this vertical rotation in y direction. The magnitude would be equal to Gj by L, and Gj is 5, length is 12, and it comes out to be somewhat 0.416, I think. Yes, 4166. It would be balanced here. 0.4166. Shoulder moments here, shoulder moment here, shoulder moment here, shoulder moment here. The magnitude would be 2 EIY by L. Now EIY in y direction is 10, and this is 40. This is 40 feet. So 2 into 10 divided by 40 gives us 0.5. That's why it is 0.5 here. I'm doing this. This is 0.5 here. So instead of writing 4 EIY by L, let me write it as 1, because it would be double of that. This is 2 EIY by L, that is 2 into 10. The length is 20 here. It comes out to be 1 again. This is fore end, this is near end, so this would be 2. Okay, I'll get this because this is in y, z direction, this is y, So there would be loading in this direction, but I am not interested because it does not correspond to D7 or Sidesway. However, let me change the pen of color of the pen. It's black. This is X, this is Y, and X and Y, the combination should be Z. This clockwise. It is forming a clockwise, so this is anti, and resist it here. We should resist it here. It comes out to be, the magnitude would be equal to 6 EI. Again, the moments are in Y, so 6 EI y L square. So 6 into EIY is 10. Length would be of this 20 square, and it comes out to be 0.15. 60 divided by 20 square. I have the calculator. 60 divided by 20 square gives us 0.15 exactly. So I needed it because it corresponding to D7. I don't need these loading because it does not correspond to any degree of freedom. Okay, finally I have to draw the stiffness elements. Everything would be having a second number of 3, 3, 3, 3, 1, 2, 3, and one more 3. 1, 3. 1. What was 1? X, Z is 2, and Y is 3. 1 is actually, so I've got nothing here, so 1 is 0, or 2, 3 is 2 is in Z direction, so I have got nothing here as well, 0. 3, 3 is in Y direction, so Y direction, so I'll have to add 2 plus 1 plus 0.4166, so it comes out to be, okay, 4, 3, 5, 3, and 6, 3. 4, 5, 6. 4 is this, 5 is 6, and 6 is vertical. 4 is 0, 5 is 0, 6, S6, 3, 0.5. Finally, S7, 3, it comes out to be 7. You have to follow the legend or the basic structure on which Ki has been identified. 7 is, I'm doing D3, 0.15, exactly in the same direction in which D7 was taken. So it comes out to be 0.15. Finally, I'm doing, I've left the rest of which are identical. I mean, 1 is identical to 4, D2 is identical to D5, D3 is identical to D6. However, D7 is difficult and different. Sorry, not difficult. So I am doing D7, and it would be very easy. So don't worry about it. Let me draw it once again, and let me draw very smoothly. D7, I have to give it an axial deformation, and it would be like this in this direction. Its magnitude would be not Gj by L, it would be Ea by L, because this is related to axial rigidity. Ea is 4, it means 4, and this is actually under axial deformation, so you have to use this length 4 by 40, and it comes out to be 0.1. It would be resisted here as 0.1. Now this would be, there would be translation in the shoulders, and you know the magnitude of translation is when you give a translation to any point in a stiffness method, it is equal to 12 EI by L cube. Okay, next thing is and that would be equal to 12 ei by l cube as well. This is 12 ei by l cube as well. All would be. Now the question is, what value of ei should be used? It should be x, it should be y, it should be z. So thing is, if you are applying this as this, you have to balance this with opposite. You have applied this, so you have to balance it, because this is fixed here, so it would be like this. So one thing has been done. Again, this is forming a clockwise moment here. This is forming a clockwise moment here, so it would be balanced with a resistive. This is z, this is x, so resistive. This is in y. Its magnitude is equal to 6 ei by l square. So this is y, because this moment is in y. Similarly, this is forming a clockwise moment here. Resistive would be anti-clockwise here, and its magnitude would be same as this. So 6 eiy, I mean eiy is 10. So 6 into 10 divided by length is 20 square. So it comes out to be 60 by 20 square. 60 by 20 square is 0.15. So it is 0.15, and it's written here. The problem remains there. I have to find the magnitude of this. So the problem is solved with solving these moments. This should be y, because the moments are produced in y. So 12 into 10, the length is 20, so you have to divide it by 20 cube. So 120 divided by 20 cube gives us 0.015. 0.015, and this would be 0.015. Now this, it would be equal to 12 ei. No, you have to find the moments. This is y, this is z, so it is producing a moment in x direction. Y, z, x. Anti-resistive would be clockwise. Its magnitude would be equal to 6 ei x by l square. Eix is 8. So 6 into 8 divided by column height is 12. So 48 divided by 12 square, it comes out to be 0.33. 0.33. Now the thing is, I have to find the magnitude of this. So I have to apply x here. 12 eix divided by l cube. It means 12 into 8 divided by length of this column is 12 cube. So it comes out to be 8 divided by 144. It comes out to 0.055. And it would be same. I mean, it does look complex, but it is very easy. Yes, you have to practice a lot. That's why I'm going to give much time for this exam. I mean, at least 15 days should be given, and I'm trying to give you at least 15 days for finding or solving such type of questions. I'm going to clear it, and finally I have to refer to legend. I mean, the legend is like this. Just let me draw. It was 1 like this, 2 was like this was 3, this was about 4, this was 5, this was 6, and this was 7. Now D7, 1, corresponding to 1, I have got this, and direction is opposite to this, so minus 0.33. S27, 2 is in this direction, and then you have to get sum of this. 2. No, sorry, you don't need to get sum, because this is moment and these are axial deformity. 27 is 0. 37, 3 is all the moments here, and one moment I have is this, so 0.15. S47, 4 is this moment, and I've got two moment here, so 0. 57 is again 0.1. No moment here, so 57 is 0. S67, 6 is moment in y direction here at this joint, 0. S77, 7 is this axial deformation, sway, and corresponding to that I have this, so I have to plus 0.015, 0.1 and 0.055, and I'll get this. So finally I'll get the matrix. One thing should be made sure that these are identity matrix, and in identity matrix S27 would be equal to S72. So anytime you can check your values. S37 is equal to S73, S24 would be equal to S42, S31 would be equal to S13. So in other words, out of 49 values, most of them are identical. I mean, you have from out of 7 sevens of 49, the diagonal values have to be found out. So 42. So out of 42, you have to find 21 values. So in total, I have to find 21 values plus 7 diagonal values. So you have to find 28 values. All other would be found out. So, but it's a complex activity. It's a tedious activity. I hope you have learned it, and I'll give you much time to solve this, because it's not easy. I mean, to grasp the concept and to transform from 2D to 3D, it takes much time.